Welcome to our INEOS Styrolution webinar. This session, we will learn about Styrolux, K-Resin, and Styroflex portfolios. These are styrene-butadiene copolymers, which are part of our wide advanced styrenics products. We will talk about these products showing key features, customer applications, and success stories, so that way you will understand why our products are the best solutions for many of your applications. We will discuss also about our new SBC ECO product lines, which we just launched back in February, and they are ISCC Plus certified bio-based polymers, which can help you to achieve your sustainability targets. Also, there will be a questions and answers section at the end, so please let us know all your inquiries by submitting them in the chat. For your reference, this webinar will be recorded and a copy of it will be available in our official website. So before we jump, it is very important for me to introduce the team of experts in SBC resins, which will be leading this webinar and answering to all of your questions. First of all, we have Dan Seagal. He's Market Development Manager for Advanced Styrenics in the Americas. Then we have Mike Hamilton. He is Technical Service Representative Americas. Third, we have Jared Rowlett, PhD Senior Product and Applications Development Engineer in Americas. And also myself, I'm a Product Manager for the Advanced Styrenics here in the region. So before we proceed with our resins, let me talk a little bit about our company, who we are, and what do we make. For those who are not familiar with INEOS Styrolution, it was formed 11 years ago, product of a joint venture combining assets of two big players in the industry to form the largest styrenics company in the world. So although we only have 11 years being INEOS Styrolution, our legacy and heritage from the previous companies plus technical expertise support us to be where we are now. We are 3,100 employees in 9 countries, having 16 production sites all over the world, headquarters in USA, Singapore, and Germany. At the bottom of the picture, you will find the 7 market segments that INEOS Styrolution has been focusing on, which includes in construction, toys, packaging, automotive, electronics, healthcare, and household, among others. So jumping into the Americas region, where do we produce our advanced styrenic solutions? We have 3 main locations in which we produce our resins, plus other 3 compounding sites. This session, we're going to focus in our plant in Mexico, specifically in Altamira, in which we produce our SBC resins, Styrolux, and K-Resin, and in the midterm future, we will produce Styroflex as well. So moving to our wide portfolio of transparent styrenics, each of them with specific key properties that fits with many applications. In the bottom part of it, we will find the impact resistance products, in which we can find as well the SBC, which are styrene, which have in common the styrene and butadiene components, which will help you to increase impact resistance and elasticity to your products without compromising clarity. So moving to the portfolio, we have a variety of products suitable depending on your application, from the injection molding grades to the extrusion grades for thermoforming. They have different mechanical properties and processability, which make each of them unique solutions. They have also good miscibility with polystyrene resins and other resins, which make them perfect for blending as well. It is very important to say that both the Styrolux and K-Resin grades are available as local production here in the Americas region, and except for Styroflex, which is currently produced in Antwerp, but eventually we will have it locally produced in Mexico. So what products can we make with all of these resins? It is time for me to introduce my colleague, Dan, who is going to talk about more of customer applications. Dan?
Thank you, Jorge. Styrolux is a clear thermoplastic styrene-butadiene copolymer, very high transparency, impact resistance, and great miscibility with polystyrene, and can be used in many different applications. Key features of Styrolux include transparency, toughness, ease in processing, low density, and cost performance. Excellent for bonding modifier with PS and SMMA, outstanding retention for common sterilization methods, and FDA USP Class 6 and ISO approved. Next. Key market application areas that we've seen include packaging, rigid packaging, trays, dead fold or twist films, and healthcare, medical devices, labware, infusion drip chambers, and compounding, shoe sole market, flooring applications, and as an impact modifier. For household toys and electronics includes pens, utensils, hangers, toys, and board games. Next, please. K-Resin is a styrene-butadiene copolymer known for its sparkling clarity, impact toughness, stiffness, and exceptional gloss. It's been used in various applications for more than 4 decades in both rigid and flexible packaging applications, including injection molding medical devices. Key values include transparency, toughness, ease in processing, low density, cost performance, excellent bonding, modifier for PS and SMMA, outstanding retention for common sterilization methods, and also has FDA USP Class 6 and ISO approvals. Next. Key market areas we've seen include for packaging, multi-layer packaging films, shrink sleeve, dead fold, twist films. Healthcare includes drip chambers, containers, oxygenators, filter housings, and blood collectors. And compounding, also used in shoe sole market, flooring applications, and as an impact modifier. Household toys, electronics, this includes bins, containers, board games, and various children's games. Next, please. Now I'd like to introduce Dr. Roulette, who will discuss SBC and interpolymer comparisons.
Thanks, Dan, over here. So we've put together a nice little table here comparing SBCs to some common other competitive resins or some resins you would use in similar applications. Here we've got PC polycarbonate, PETG, SEBS, and clarified olefins. What you'll notice here for SBCs versus these other resins is this nice impact and stiffness combination here. So SBCs are very tough, provide a lot of impact, but also have very good stiffness for your applications as well, especially when comparing to SEBSs and clarified olefins. Of course, SBSs are typically just hydrogenated versions of SBCs. What you also notice is that clarity, excuse me one second here. Clarity and processing are a big advantage for SBCs over common other resins. SBCs are known for their extraordinarily good optical properties and their clarity and low haze for it. Additionally, like all styrenics, SBCs processes extraordinarily well. So you have very ease of processing, very low temperature, very quick cycle times, which provides a nice advantage over similar competitive resins. And when comparing to PC and PETG, you get a very nice density and cost advantage for these resins as well. Additionally, you can expect very good chemical resistance and moderate heat resistance for SBCs as well, making it a perfect choice if you need to have that balance of stiffness and toughness, and you want outstanding optical properties for your resins. Go ahead, next slide. So as mentioned in the previous slide, when you compare against copolyesters, PVCs, and PETG, you get a nice benefit in specific gravity, which is density here. Which means if the specific gravity is 15 to 25% lower for the SBCs, you're getting 15 to 25% lower weight. So one part will weigh 15 to 25% less for SBCs versus these other resins, which means that not only are you using less pounds per part, which means you're buying less pounds per year, but you're also contributing less waste as well. So there's a nice sustainability aspect as well. So you're using less plastic, so less plastic is going into the waste for it as well. As mentioned, your processing is a big advantage over these. So your cycle time can be anywhere from 5 to 15% faster. Your processing temperature can be 50 to 70% lower. And typically our scrap rates are less than 2%, which is outstanding. And even if you do produce some scrap, it's easy to regrind it and use it back in the process, which is not always the case with some other resins here. And we have found that the regrind use can be up to 70% better than some of our other competitive resins here for it. Like most styrenics, drying is almost never needed. So you'll save money and time versus drying and utility costs for it. And the flow is typically outstanding for SBCs, which leads to the lower processing temperature and the faster cycle time for it. So altogether, you could expect a material savings from anywhere to 10 to 30% and a manufacturing savings from 5 to 10%. So making it a nice benefit to go along with these outstanding properties we displayed on the previous slide as well. So with that, I will turn it back over to Jorge here.
Thank you, Jared. And as you may have seen in our social media lately, we just launched a press release about our ECO grades in the region. But what is ECO? K-Resin ECO and Styrolux ECO are bio-attributed drop-in solutions. What's that? That means exact same characteristics and performance that our fossil resins, but produced with bio feedstocks. This can be possible due to the mass balance approach with ISCC plus. That way we ensure biomolecule traceability throughout the supply chain from the region to the final application. With this, we ensure sustainability while maintaining same INEOS Styrolution quality performance standard. In the picture below, you can see that both renewable feedstock and fossil fuel or natural gas comes into refinery to produce naphtha in case of the fossil fuel, or bio-naphtha for the renewable feedstock. This will go into the syngas or steam cracker plant to get basic organic chemicals. In our case, biostyrene. So in this material, raw materials will go into our chemical production plant. In this case, Altamira, Mexico, which is now certified in ISCC plus to obtain bio-distributed styrenics that we can provide to you and to our customers as a Styrolux ECO and K-Resin ECO. But what is ISCC? This is International Sustainability and Carbon Certification, and it's globally applicable sustainability certification system, which covers all the sustainable feedstocks, including agricultural, forestry, biomass, circular, and bio-based materials. What does attribution mean? Attribution means that renewable feedstock is mixed with fossil feedstocks during production. The amount of renewable material used is tracked and an equivalent amount is attributed to the end of the product. The bio-based content is allocated using the certified mass balance approach. With this, not only we can give you credits on the ISCC plus balance, but we can also, based on the numbers that we identified as a reduction, we can give you a reduction of lower carbon footprint. That way you can achieve your sustainability targets as a net zero emissions. These numbers are a reference from our manufacturing centers in Europe, but we will soon have our new numbers here in the region of the Americas. And now it's time for Mike to talk about Styroflex. Mike.
Thank you, Jorge. Styroflex is our unique Styroflex thermoplastic elastomer, styrenic-based material. It's also used in many extrusion applications such as cast film, blown film, and even injection molding. It offers good processability, rubber-like mechanics, outstanding toughness, extremely high tear and perforation resistance, low density. It can also be used as a compatibilizer with other polymers. And in most cases, it also offers down gauging opportunities. As you can see from the pics below here, the Styroflex 4mm film was stretched over a bowl, cycled by pressing a ball back through it there, as you can see to the bottom of the bowl. And then at the end of the far right pic there, you can see the material comes back clear into its original form. Next, please. Styroflex is used in many applications, such as packaging. Styroflex is used in stretch films, stretch hoods. It's used as an additive for environmental stress cracking resistance. In the healthcare market, it is used in drip chambers, IV devices, tubing, and collection bags. In the compounding segment, Styroflex is used in flooring, regrind for PIR and PCIR, and it's also used as an impact modifier in lots of resins. Next, please. In the stretch head market, as you can see from the video playing here, a stretch head basically is a film that comes down. The machine grabs each four corners of the film, stretches it over the pallet, and then it is released. What this does is basically the holding force of the film itself holds the contents of the pallet in check and also offers protection. Styroflex is uniquely suited for this application due to its high elasticity and clarity and high puncture resistance. Why use Styroflex in stretch headers? Well, typically a olefin-based roll of film would be much wider and thicker. With a Styroflex-based film, typically you would have a narrower base film and also a film that's down-gauged. It can also be produced in existing stretch hood equipment. You have better processing, increased clarity. It is fully recyclable, puncture resistance, has good mechanical properties, and good elasticity. Next, please. As you can see here, down gauging offers a better opportunity for a good film here. So what we did here is we combined a typical 4 mil standard olefin-based film to a 3.2 mil Styroflex based film. As you can see here, a typical 4 mil film would weigh up to like 200 pounds, whereas a Styroflex film would be a 160-pound roll. Its elasticity on a base 4 mil film would be 20 to 50%, whereas Styroflex would be up to 200%. Thus, the reason for having a much thinner and a smaller roll for the stretch hood application. You also, because of the down gauging of the film, is also a cost savings. Sustainability efforts, basically using 20% less resin consumption, offers you're going to get. With that being said, you're going to get a lower carbon footprint, which is reduction by consumption. And also what we have found, when you utilize PIR or PCIR content in a typical olefin-based film, and many times you can get up to 2 times more loading with a Styroflex-based film. Also, logistics equals 20% more rolls in the truck due to the smaller roll size. As you can see from the pic here at the bottom, a Styroflex-based film would basically contain about 50 to 60% in the B layer, the core layer, which is compared to an olefin-based film, which you would basically have that olefin-based elastomer in the core. Next, please.
Thank you, Dan. Thank you, Mike. And now it's time for the people in this webinar to let us know their inquiries and by publishing the questions in the question and answer section, and we will address it. We have one question here, which is, how do I know which product to use for my application? Dan?
Absolutely. Thank you, Jorge. What a great question. We work with our customers to determine the application needs and the properties they're looking for, and can help you reverse engineer a structure or develop a new structure based on the performance criteria and your manufacturing operation.
Thank you very much. We have this second question. It says, do you provide technical service in field? Yeah, Mike, can you please respond to that?
Yeah, thank you, Jorge. Yeah, absolutely. We love to work closely with our customers so that we can best understand what their targets and goals are. So we offer on-site technical support. Along with that comes our team of professionals here, where we can also help you with testing if needed. And of course, we get down to all the targets that you're trying to hit, and and take it from there.
Thank you very much, Mike. We have one more question. Is UV stability offers in the stretch hoods since they are an outdoor application? Jared, could you please help me with this?
Mm-hmm. Of course, Jorge. Yeah, thank you. Yes, in stretch hoods, they can be made UV stable. It depends a lot on the structure and how you organize it. And we'd be happy to take questions to discuss it further if you contact one of our colleagues here for it.
Thank you very much, Jared. We have another question. What percentage of Styroflex 2G66 is recommended to use as a compatibilizer in ABS and HIPS mixes? Mike?
Yeah, great question. In many cases, what we have seen when we're working with compatibilization, we typically want a minimum of 8% loading of Styroflex. Now, with that being said, also, since you're only using a small amount, you also need to consider if there's other properties you're trying to maintain or enhance. We'd be glad to work with you on that and make some recommendations and how to incorporate the Styroflex to get the best bang for your buck there.
Thank you very much, Mike. We have another question. When will eco grades will be available for purchase? Well, actually, since we launched this on February 14th, we have eco grades available to supply from our Mexico plant. So please send us a note to Dan Tegal or myself, and we will respond to your inquiry. Thank you. I think the same person who asked of the mix of compatibilizer of Styroflex from ABS and HIPS is asking another, and what about polyethylene and polypropylene mixes? Could you please comment on that, Mike?
Yeah, again, there I would stay with the 8%. What we found with a lot of the compatibilizations that we've done in the past, whether it be olefins or other styrenics, or even those added all in one, we typically start out at 8%, and that has worked very well. I just have to stress the importance of dispersion, because as you know, if you're adding in a small amount, you need to get that dispersed very evenly and throughout the matrix of the polymer. But absolutely, depending on your equipment, we'd love to work with you on that. And again, we would start out at 8% and then go from there.
Thank you very much, Mike. And we have one more question. What is the main difference between K-Resin and Styrolux? Jared, could you please help me with that?
Absolutely. Yeah, so K-Resin, Styrolux is a special molecule actually for it. So it's our linear one, it's a high elasticity. Most of our Styroluxes and our K-Resins are more what you would call thermoplastics. And Styroflex is more like an elastomer for it. So it's sort of like a special polymer by itself here for it. Whereas your K-Resins and your Styroluxes are much more like TPEs for it, or thermoplastics, I would qualify it. So hopefully that answers the question there for it.
Yep. Thank you, Jared. So there are no more questions right now. So I think we can have this webinar ended. Thank you very much for attending this webinar. And if you do have any other questions after this webinar is finalized, please do not hesitate to contact your account manager, Dan Tegal, or myself, Jorge Ruiz, at these addresses, or visit our website, in which you can find publications and videos, brochures and webinars, and other useful material, as well as TDS and regulatory documents from our products. Thank you very much for attending this webinar. And have a good rest of your day.
Thank you.
Thank you.
Thank you.
Driving success together.